Welcome to Unit 9, Lecture E. We're going to talk about industrial applications of redox quickly. One of the biggest uses of redox as far as industry is concerned is in the reduction of metals. So very few metals are found in nature in their pure forms. They're mostly in what we call ores. Ores are any kind of mineral rock that contains a high percentage of a desirable metal in it. So iron oxide, sodium chloride, anything can be considered an ore if we want one of the metals out. For the metals in group 1 and 2, they're so highly reactive that the easiest way to obtain them is to do electrolysis, and we use their fused salt, fused meaning they're melted. So if we have this fused salt, and notice I have a typo here, this should be calcium chloride, calcium plus 2, the chlorines are minus 1. We run electricity through it, we can get the individual pieces to go to the electrodes and go into their pure forms. So if you want to get pure sodium, you have to use an electrolytic cell in order to do that. So that's for group 1 and 2. You're going to do electrolysis. I don't think I need to write out the half reactions. We've seen enough examples of those. That is for small amounts of those highly reactive metals, but on a larger scale for things like aluminum and iron and copper, things that we use a lot, that would take too much energy to get them out. These metals are not as reactive, so we can get them out by putting them with a strong reducing agent. So if we want the chromium out of this chromium oxide, we can put it together with aluminum. The aluminum 0 here, this chromium is plus 3. Over here, the aluminum is plus 3 and the chromium 0. Because aluminum is higher on table J than chromium, it's more likely to be oxidized, so we put these together with heat. The aluminum gets oxidized, the chromium is reduced, single replacement reaction, and it's redox. Big plants, steel plants used to be down in Lackawanna. Right now, you're hearing a lot about these coke plants and the news for environmental problems. We do this thing called roasting. So the sulfide ores are converted to oxides first because then we can reduce the metal out of the oxide just by using carbon, and so they're going to give off carbon monoxide or carbon dioxide. So the first thing we do is we want to get rid of this sulfur. So this sulfur that's minus 2 here, we burn it with the oxygen, and the sulfur goes to 0, and the oxygen goes to minus 2. So at the first step, the metal is not changed at all. Then we take our oxide, react it with the coke, which is a form of carbon. Remember, carbon has many allotropes. And we get our copper then into its pure form. And we've made carbon monoxide. Or it could be carbon dioxide if the carbon happens to be a plus 4 oxidation state. There'll be some carbon dioxide. And then your metal's in the pure form. So notice the oxygen is a spectator ion. What's happening here when you react it with the coke is that the copper gains electrons and becomes reduced, and the carbon is going to lose electrons and become oxidized. One of the big things with redox as far as industry goes isn't really to do the redox reaction, but to stop the redox reaction. So we have several ways that we use what we know about redox to stop the oxidation of the metals. So the first one is that some metals form self-protective coatings. So we know that aluminum and zinc, when they become aluminum oxide and zinc oxide stick to aluminum and zinc. So it makes its own protective layer. So if we galvanize a piece of metal, we do electrolysis and we coat it with zinc, we know the zinc's going to turn into zinc oxide and it protects the iron that's underneath. When we have iron, iron oxide doesn't stick to iron, And so once it oxidizes, it flakes off, meaning it exposes more iron to oxidation. Eventually, you get a hole through something. So we're going to try to protect that iron. We will galvanize it or plate it with aluminum or zinc. We can coat it with some really pretty ones like chromium, but that tends to be more expensive. Sometimes near tanks or near bridges in the water, we'll put a chunk of a more reactive metal near it. So the reactive metal attracts all of the electrons. So the reactive metal is the one that's oxidized and it keeps the other metal reduced. We can also alloy them. Remember, an alloy was a metal mixture. If we alloy the iron with nickel and chromium, we make something called stainless steel. Different combinations of metals, and with iron makes different types of steel, and that will slow down the corrosion. Stainless steel corrodes very little at all. And then the cheapest way is for us to coat things. So we paint them, we coat them in plastic, we coat them with glass. You undercoat your car with oil. We run oil through the parts of our car itself and the engines. All of those things that we do to try and stop the water and air from touching the metal itself to slow down the oxidation. Those are the things that you need to remember, and that wraps up redox.